Now we will discuss some other questions regarding the real numbers. As many as questions you will solve, it will enhance your thinking power, imagination power, and you can solve any problem of any type with your own caliber and own practice. So another question is, if root AB is a irrational number, prove that root A plus root B is also an irrational number. So proof. Let us assume that root A plus root B be a rational number, which is as usual. Then you will arrive at a contradiction. So say R. This root A plus root B is equal to R, where R is a Q. In this place we have not written R to be as P by Q. Simply R is a rational number, where A and B are rational numbers. It is given A and B are rational, such that root A plus root B is equal to R. This implies squaring both sides. Root A and root B plus root A plus root B is equal to R. It is taken as to be a rational number, which is R. Now squaring both sides, this will give root A square A, root B square B plus 2AB, 2 root A into root B. This is equal to R square. This implies root A plus root B. These are the two irrational numbers or root over term. These are free from root over. So totally these are two rationals. Take it to this side, because R is rational, R square is also rational. So totally it is now taken to be a rational number. This implies root A, root B, root x into root y is equal to, you can take whole root over x into y. In this way it is written, this is equal to this is equal to R square minus AB divided by 2. Here you can again see here, R is a rational number, R square is also a rational number, A and B both are rational numbers, minus A minus B are rational numbers. Total rational minus rational is also plus minus into division. Everything is always a rational number. Division by 2 is also a rational number. Here 2 not equal to 0, it is already there. So root AB is a rational, which contradicts to the given data that, but what is given? Given that root AB was irrational, but you arrived at that root AB is rational. So this contradicts. So what we will get? Root A plus root B is automatically irrational number. All this is, so no much time. I am not spending much time on these things. Whatever I have written here, you can see in the screen, and you just go there. If there is any omission or commission or any problem or doubts, you can ask me in the comment. I will elaborately or I will discuss it in details. But I hope in whichever way I have written in this khata or in this note, it will be clearly elaborated, and there is no any omission, commission or omission of steps which may put you in problem. I have detailed each and every step, for which it will be more easier to you to understand the solution of the problem. So it is a particular case I have discussed here. It is root 15 is equal to root 3 into root 5, that is equal to, and this is irrational, root 3, root 5 also irrational, and their summation root 3 plus root 5 is always irrational, because we have read earlier that irrational plus irrational may be irrational, may be rational. It is now, it is irrational, it is okay. It does not violate. Sometimes then it may be rational, but now it is irrational, because root 3 is irrational, root 5 is irrational. Now solve another question. So that 5 minus root 3 is an irrational number. We have read earlier that rational plus minus irrational is always irrational, but it is one thing is, it is always. Here it may be irrational or rational, but in this case it is irrational. But in this case 5 minus root 3, one is rational, other is irrational. Plus minus does not matter. if there are two types of numbers, one rational and other irrational, and either you add this or you subtract this, always it will be irrational number. It is, I have told you in details in some previous classes. Let, how to prove this? Let 5 minus root 3 be rational number and say it is in the form of a by b. Sometimes we are writing directly the rational number as r, or sometimes we are writing it in p by q or a by b as the situation arises. There is not a concrete thing that always you will write a rational number to be p by q. You might write sometime r, s, t for convenience or for easy proof. Okay. Then 5 minus root 3 is equal to a by b. This implies root 3 is equal to, you take root 3 to this side, a minus b to the other side. So 5 minus a by b, because root 3 is a root over term, but there is no root over, it is clearly rational. 5 minus a by b. This implies root 3 is equal to 5b minus a by b. Since 5b a belongs to I, integers implies, and b is not equal to 0. It is previously written, this time it is b is not equal to 0, and a and b belongs to integers. This implies 5b minus a by b is also a rational number, because this is a p, this is q, in the form of p by q. Number root 3 becomes a rational. You arrived at that, root 3 becomes a rational, which is not possible. We know that any prime number, its root over is always irrational. So again you arrive at a contradiction that this is rational. So what was our assumption? 5 minus root 3 is rational to be wrong. What is the correct? 5 minus root 3 is rational number. Without taking a by b form, we can directly taking a to be a rational number. Then 5 minus a, 5 is a rational, minus 1 is a rational, 5 minus a is a rational. Any type, by any way, either take a by b or simply a. When you are taking a by b, one thing to remember, when we are taking a rational number, irrational number, whenever you are taking an irrational number as p by q, q belongs to I, q does not 0. But when we are taking a, this time a belongs to q. Directly we are taking a to be a rational number. But it is p by q means p is not rational, q is not. It is p is I, p also in I, q is also in I. Then only we are writing this is the difference. Only in your notation or your writing you will this. If it is a, you write a belongs to a q. If you are writing p to q, we write p, q belongs to I, where q is not equal to 0. For your proof. This question, it is some harder question. Those the aspirant students who are so curious about the number system and who has some interest to go in deep in about the study, he may done all these things. It will enhance their IQ. Just you can, after proving this question, you will imagine why I told all these things. So let us study the question. Two positive numbers have their HCF 12 and their product is 6336. The number of pairs possible is, here two positive numbers is given. Their HCF is given and their product is given. Product is given, HCF is given. What was the formula to we know earlier? HCF into LCM is equal to product of number 1 into number 2. We are given that the positive number, the HCF is 12 is only given, and their product is, What will be the LCM? We can find the LCM, but can we get number 1 and number 2? Concrete number, the exact number? No, from only one equation, there are two unknowns, 1 and 2. We cannot find the exact solution. So there may be possibility of many solutions. That question arises here. That question arises a pair of possible. What are the pairs of number 1 and number 2? For which their HCF will be 12 and their LCM, their product will be this, their HCM will be 12. No LCM is given. How will get the LCM? Product of two numbers. We can also get the LCM by the division, but it doesn't matter that HCF is given, LCM is given, you can find out the numbers. No, it is not possible. For example, in this, after solving this question, I will clearly give a clear vision of this. Let the two numbers be x and y. Let us factorize 636. We get, what is the factors? 2 to the power 6, 3 square 11. Since HCF is 12, we can first choose x to be the HCF itself, i.e. x is equal to this. Always remember that whenever two numbers has HCF is, suppose x, number 1, number 2. So it is a factor of number 1, x is a factor of number 1, x is a factor of number 2. So x is equal to this 12 and y is equal to, since 12 is the HCF, so 12 is inside this, 12 is a factor of x, 12 is a factor of y, because these are two numbers and the numbers of HCF is 12. So in which way you can express 12? How many process? Only one process, because factorization is always unique. So in which way you will factorize this? What are the unique factors? The prime factors, unique. No? What are the prime factors? The prime factors are 2 square into 3. This is the only one. That is 2 into 2 into 3 is equal to 12. We can express 12 only in this way. These are the prime factors. Similarly, y has this, because 12 is a factor of x and 12 is a factor of y. So into 2. Why I wrote this 2 square into 3? Here I write 2 square into 3. No, this one. 2 square into 3, 12. Then y has. So x will be 2 square into 3y. Then y is equal to, if I write suppose 8 and 10. What is the HCF? HCF is equal to 2. We know this. So I can write 2 into 2 as x, HCF itself. So what will be 10? 10 is equal to HCF into another number. Automatically, if this is the HCF, what will be the number of y? Y will be 10 into x. Let us factorize. We get HCF. Let us first choose x to be the HCF. The number, initial number which was taken as x, take is at the HCF. There is no fallacy or no problem or no complication will arise. Let us take this is the first number. It is the second number. And this first number to be, it may not be always. This 8 is first number, 10 is second number. Is 8 is the HCF? No, 2 is the HCF. But here we will let us take x to be the HCF. Then if x is the HCF, it will be 2 square into 3. It is given because 12 is given. 12. Then what will be this number? Second number. Always second number is HCF must be there, because that factor will be both in x and y. So HCF into some another number. So what will be that another number? If you will divide this 2 square into 3 by HCF into 2 into 11, because 6, 3, 3, 6. This is the product of two numbers. So what are the factors? It is written here. 2 to the power 6 into 3 square into 11. Now you factorize, you divide it into two parts. One is the HCF factor, the other is another. So what is the HCF factor? 2 square into 3. What remains here? 2 square. 2 to the power 4 into 3 into 11. That is the remaining term, remaining factor. So if 12 is there, only the remaining factor 12 is HCF, leave it, will be this. So you can verify 12 into this one. This is 528. This will be 520. HCF is, leave this. This will be 528. Okay. Now we can multiply x by 2 and divide by 2. What are the factors now here? 2 to the power 2 and 11. So you take 1 2 here. 8 into 10 is equal to 8. Suppose I have written it, I can written this 4 into 20 is equal to 8. If you divide 2 here, multiply here, there is no problem. What will get? 4 into 2, 8 by 10. Again, if you multiply 2 here, you divide 2 here, because multiplication gives a result. If you divide one number with one factor, you have to multiply the same with the other factor. Suppose you are dividing 2 here, you have to multiply 2 here. What will happen? 16 into 5 is equal to again 80. This process is applied here. So take x. X is now not the HCF. X is some other number. What is this? X is equal to 24. That was 24. First 24. 2 multiply. 1 2 will be reduced here. Then, but in this case, if you will do this, what will happen? Initially it was, you look this, initially it was 12, here it was 2 factor. Now I multiplied here 2. Again it will be 2, 11 factor, this will be multiplied by 2. Again 2 factor is in both sides, both numbers. What it will affect? If 2 numbers again, 2 factors again in these 2 numbers, the HCF will be 24 at that time. It will enhance, so it will give a contradiction that we have taken 12 to be the HCF, so we cannot take this. This pair will be not be there. What will be the pair? 24, and this is another number 24. The number will be 12 into 2. 2 square is not there. This 11, another number. But this will not there, because if you take this 24, it will be 24. So the now HCF will be 24. Come to the next thing. Another 2 is there. If multiplied by 2, what will get? 24 into 2. 24 into 2 is equal to 48. Now it will no 2 is here. No more 2 is here. It is now 2 square. The same HCF is there. And only 11. So 12 into 11 is equal to 132. Now this side comes to what? 24 into 2. 24 into 2 is equal to this 12 into this. 12 is. Now you can verify that only 12 is the HCF. No further 2 is here. 12 means 12 into 2 into 8 into 2. This is equal to 12 into 11. This number, this number. What is the HCF now? 12. So finally we arrive at that this is possible, because it does not hamper the HCF 12. So what is the number now? So it is seen that x is equal to 2 square into 3 into 2 square. The next case, 11 is 1, you take this 11 to this side, 11 divided. What will be y? Y will be only the HCF as in the first case. What was x? It is now y. The HCF is now the y. So it will be the repetition of the first. Repetition of the first. So what is the only possibility? These two. After solving, you will clearly, the doubts, it will be clear now, right now. X into y is equal to 6, 3, 3, 6. First, x to be 12 into y is equal to 5, 28. 12, 8, 5, 28. First. In this 528, 12 into 2 square into 11. Okay. Second, 12 into, total you take this, 2 square into 12 into 11. 2 square will reduce here, you multiply here means you will divide by 2 square. This is also 3336, is also 6336. So this value is 12, 528. This is 48 into 11, 12, 132 is equal to, okay, only these two pair. What are the numbers? 12 first, this into this. So 12 into 528 and 48 into 132. These are the only two pairs. Why not the middle one is left out? You verify this one. Suppose 12 into 2, 24. This will be reduced by 2. This 528 by 2. This is equal to 2, 6, 4. But it is 24 is a factor. Okay, 24 is a factor. In this number, 24 is a factor. Then what will be the HCF? Not 12. There will be a wrong question. A wrong answer we will get. We will not get the HCF 12. So we can, in this way, we can find out the pair of how many pairs we can construct, which is not clearly given. Only to the product is given, HCF is given. So we can, at our sweet will, we will prepare the pair of two numbers, but that sweet will does not matter. Whatever number we think, we can put that. No, we have some restrictions that the HCF is always to be 12, but in this case the HCF comes to 24, which is wrong. So only these two numbers are possible. Only these two numbers are possible. Okay. Now another deep question, deep study is this. It may not be asked in an examination because it is a very hard question. But due to curiosity, I think I will express it before the students. They can go in details. Only you read all these things up to whatever written here, all these things. And the most important thing here, I will give you some clarification. You just read this, you can understand clearly. I do not want to spend some more time, but only one thing, some exponent forms which you might have forget, that I will want to memorize you. That is it okay? Is it correct? Suppose a to the power x to the power y, a to the power x to the power y, a to the power y to the power x, whether all these things same or different, just to, it is used here. I want to elaborate you. A to the power x to y by the process of exponent it is always first is x to the power y, first x to the power y, then a to the power xy, means this. But this is a to the power x to the power y, means a to the power x into a to the power x into a to the power x y times, as x cube is equal to x into x into x. Similarly, a to the power x to the power y means a to the power x multiplied y times. This is also equal to a to the power x into y. Now, a to the power y to the power x, a to the power y into a to the power y into a to the power y x times. This is also equal to a to the power y into x. This is equal to a to the power x into y. So what do we get now? A to the power x to the power y is equal to a to the power y to the power x. But a to the power x to the power y is not equal to a to the power x to the power y. For example, a to the power 3 to the power 2, a to the power 3 to the power 2. This meaning is first you take the power of 3 to the power 2, the a to the power 9, but this is a to the power 3 into 2, that is equal to a to the power 6. So this is the difference. That aspect is used here. Prior to this, I want to express. Suppose 12 to the power n. 12 to the power n. What is the unit digit? 2 to the power n. You put 2 to the power n. Okay, 12. 12 to the power n. Number is 12. What is the unit place? Unit digit is unit digit 2. Then it's 2 to the power n. So 2 to the power n, what will be the possibility? 2 to the power n means it will 2 to the power 1 is equal to 2. 2 to the power 2 is equal to 4. 2 to the power 3 is equal to 8. It is so for each and every different, there are different unit digits we are getting this. But two to the power 3x, whatever the maybe 3x, is always has always factors 2. No other prime factor is there, because 2 to the power 3 means 3 to the power 1. 2 to the power 3 means 2 into 2 into 2. 2 to the power 3 square means 2 to the power 9, that is 2 into 2 into 2, 9 times. 2 to the power 3 cube, 2 to the power 27, 2 into 2 into 2, all these things. Now 18 to the power 3x. Now the unit place is 8 to the power 3x. If x1, 8 to the power 3. If 8 to the power 3, 2, that is 3 to the power 1. 8 to the power 3, 8 to the power 9, 8 to the power 3 to the power 3, 8 to the power 27, all these things. Now, the question says the value of 12 3 to the power x plus 18 3 to the power x, x belongs to n, and with digit 280d cannot be determined. What will be the end digit? How we will solve this? First of all, we have taken let x to be 1 and x to be 2, and you verified that all these things happen every time we get 2. It is just taken a particular case. But what will be the general case? Whether everywhere it will be 0. We take particular case 1 is 0, taken 1, the end is 0. Taken 2, the end becomes 0. Is it mean that for whatever x is taken, it will be always 0? No, it is not the proof in mathematics. We have to generalize it. So the generalized formula is, it is used here. Let us see. 2 to the power 3x plus 8 to the power 3 to the power x. Because question is like that. The question was 12 to the 3x plus 8 into the unit digit is 2, the unit digit is 8. So now you just screening out 2 to the power 3x plus 8 to the power 3x. The unit place, unit digit. 2 to the power 3x plus 8 to the power 3x. Now this can be written as, this 8 to the power 3x can be written as, it is kept, it is okay, no problem. Now this 8 is 2q to the power 3x. We have earlier, I have told you earlier this, that x to the a to the power x to the power y is equal to a to the power x into y. This can be written as 2 to the power 3 into 3 to the power x. This can also be written 2 to the power 3 to the power x into, because a to the power x y is equal to a to the power y into x. This is equal to a to the power x to the power y is equal to, this is equal to a to the power y to the power x. This aspect is used here. Why it is used here? You see, 2 to the power 3 to the power x, 2 to the power 3 to the power x here. Okay, now it is a factor. Whenever you are adding this, you have to add this. You are adding this. Suppose 5 into 6 into 5. What you 5 you can take common, plus 5 to common, 1 plus 6. Similarly, when you are adding this 2 to the power 3 to the power x take common, it will be 1 plus 2 to the power 3 to the power x. When it is taken, suppose x to the power q, you are taking common x. What will be there? X to the power 2, 3 minus 1. You are taking, whenever taking common x, x means x to the power 1. So taking 1 common, whenever you are taking 1 common, it will be x cube, x to the power 3 minus 1. Similarly, when it is transferred to this way, this will be 2. Because what is the power? 1, it is power 2, 3. But this is the most important thing here. What we are expecting, again you have to change this. You have to change this because 4 to the power 1 is equal to 4. 4 to the power 2 is equal to 16. 4 to the power 3 is equal to 64. 4 to the power 4 is equal to 4 into 4, 6. 4 to the power 5 is equal to 6 into 4, 4 into something. So whenever it is odd, 4, 1, 4, 3, 4, 5, whenever the power is odd, it is always, the unit place is 4, always, when it is odd powers. Now 2 to the power 3 to the power x square. 2 to the power 3, 2 to the power 3x is equal to 2 to the power 3, 3x is equal to 2 to the 3x is equal to 2 to this one, 2 to the power xy. I have narrated you earlier. Now come to this 2 to the power 3. Now again you can express it. What is this? 2 to the power 3x to the power 2 is equal to 2 to the power 2 into 3 whole to the power 3x. This is as a to the power x to the power y is equal to a to the power y to the power x. I have written earlier. So for all x 1, 2, but 2 to the power 3x always a factor of 2. It is a always has factor 2. This aspect factor 2. It is a unique prime unit factor. prime factor only 2, and 2 to the power 2 to the power 3x, 2 to the power 2 to the this is changed to this. How? 2 to the power, you see, 2 to the power 3 to the power x whole to the power 2, now changed to 2 to the power 2, 2 to the power 3x. How will you change this? Because a to the power x to the power y is equal to a to the power y to the power x. This is, first it was here, this comes to this comes to this. Okay, 3x, 3 to the power x, interchange, xy, yx. This way. Why it was taken? Because, what is this number? 2 square. What is 2 square? 2 square is 4. Written 4. 2 square is, so 2 to the power square to the power 3 to the power x. So what is this? 4. What is 3 to the power x? If x is 1, it is 3, x is equal to 2, it is always odd. You verify. In a which technical way, in a genuine way, or we are changing this to this system. So always 4 to the power 3x is always odd. 3 to the power x is always odd, because 3 to the power 1 is equal to 3, 3 to the power 2 is equal to 9, always odd. So whatever we have verified this, yeah, whenever the power of 4 is odd, it is the end digits with, and the end digit is always 4. So this digit is always 4, this digit is 1. What is their summation? Is equal to 5. And what is the factor here? 2 is a factor always. So what will be the resultant in general? It is always 5 into 2 is 10. The end points is 0. So it is the general formula of this. If someone is interested to know in details, if they have some interest or there is any doubt or they do not understand properly, they will ask me through comment. I will also give some 5 to 10 minutes to clearly to discuss about this. Okay. Now, another question. The sum of two numbers is 520 and their HCF is 32. Then find the number of pairs satisfying the above condition. As earlier, previous example. Now, let the numbers are 33x and 33y. HCF is 33. Why I wrote in this way? Whenever there is a HCF, HCF into some number and another is HCF to some number. So, 33x plus 33y is equal to 528. This implies x plus y is equal to 528 by 13, that is equal to 16. It is another way of writing, solving this problem. Since the HCF 33 is already taken to account during calculation of x plus y, we should choose x and y in such a way that their sum is 16. What is this? X plus y is 16, but their HCF is taken already. The HCF of the numbers are 33, but that their sum is 16 and they have no common factor, otherwise HCF. The same way, when we are taking 24 in the previous question, it was become the HCF became 24. HCF became 24, which was wrong because the HCF was given 12. In this case, if we should choose x and x plus y is equal to 16, that their sum is 16, they have no further common factor, otherwise HCF will change. So in which way we will take the numbers, two numbers, such that it will not affect their HCF. So this 15 can 1 plus 15, it is x, it is y. Is there any common factor? Co-primes. No, that will not affect their HCF. So x and y, the co-primes, only the co-prime factors we will take here. Otherwise it will affect the, suppose we are taking 8 and 8. What will happen? When we are taking the multiplication, because their HCF will enhance to 8 times. If you take 16 is equal to 2 plus 14, 2 is common in both. So we have to take only the co-primes. There, at that time, it will not affect the HCF. So what are the co-primes? That their summation is 16. 1, 15, 3, 13, 5, 11, 7, 19. So what are the numbers? The numbers will be 33 is the HCF, 33 into 1, 33 into 15. That is the process of HCF and the number. 3 into 3, all these things only 4 pairs. No other pair. What are the remaining? Suppose 2 and 12, 2 and 14 cancelled. 3, 4 and 12 also cancelled, because it is 4. The HCF will increase by 4 times. Here the HCF will increase by 2 times. The other one is 6 and 10. The HCF will increase by 2 times. Okay. So this is the solution. Now, a circular field has a circumference of 360 kilometers. 3 cyclists start together and can cycle 48 kilometers, 60 kilometers and 72 kilometers per day respectively around the field. After how many days they will meet again? The question is that the circular path is given and the speed of the persons is given. He is asking that from a certain point, suppose from this point, all 3 started their journey. They will move, either they will one day they will complete it totally one revolution or to some distance, but as their speed is less, speed is different, they will cover different distance per day. So 70 per day. What are their speed per day? One is per day speed is per day speed is 48 kilometer, 60 kilometer and 72 kilometer. Now you think that after one day in this circular path, one will cover 48. Suppose this is the starting point. It will cover 48 kilometers. It will cover 60 kilometers. Another person will cover 72 kilometers. So on the single day, they will cover different distance. Will they meet again? Yes, they will meet again, but on how many days? After how many days they will meet again? The question, just you think a little bit, if within 2 days it will cover 48 into 48, he will cover 120, he will cut 144 kilometers. But the total circumference is given 360 kilometers. 360 kilometers. So only taking the LCM or HCF of 48, 60, 70 will not give the concrete result, because here is the speed is given. Some different thing is to be taken. That we will discuss now. But after 360 kilometers, how many times it will take? How many days it will take? How many time it will take? So the question says, find the days. After how many days they will meet together? By that time, the speed of 48 kilometers will take much days. The time 60 kilometers will take some lesser date, and the speed which is 72 kilometers, it will take least days. So how to find out this? Just you see, first one speed is 48 kilometers to cover 360. 15 by 2 days is required. So for this total 360 kilometers, 15 by 2 days is required. For 60 kilometers, 6 days is required. For 72 kilometers, 5 days is required. Now the LCM, we are now want to find out the days, common day. So now from speed we transfer to days, because it is the question after how many days. The days has been asked, not the speed. So from that day we will count the LCM or HCF. In this case, it is the LCM is required. So LCM of these days will be calculated. So 15 by 2, 6 or 2, the LCM, where the LCM of a fraction, there is some little difference to the LCM of a number. So how we are finding out the LCM of a number? The LCM of a number is LCM of a fraction, LCM of numerators divided by HCF of denominator. This is the process, because it is a fraction, 15 by 2. So 15 by 2, LCM of numerator, what are the numerators here? 15, 6, 5. What is the LCM? 30. HCF of what are the denominators? 2, 1, 1. Because 2, it is here it is 1 divided by 1. 6 by 1 is 6, 5 by 1. So it is 2 divided 2. This is equal to 15. It is 15, 6, okay. It is 30. This is 1. HCF of 2, 1 and 1 is 1. So it is 30 days. Okay. After 30 days they will meet again. So after 30 days they will meet again, means they will reach here. How? Just to verification, whether it is your result is correct or not. How will you verify this? After 30 days it will cover per day, one day 48 kilometers. 30 days into 30, 3 into 8. This is down here, 1440 kilometers. First. Second, the speed is 60 kilometers. 30 days I will kill. After how many days they will meet again? 30 days. 30 days, 1800 kilometers. In 30 days you will cover 72 kilometers. But what is the total circumference? 360 kilometers. One round 360, second round 720, third round this. How many rounds? 3 rounds the circle, because 360 into 3 into 4 into 4, it is 4. It is 4, not 3, it is 4. Okay, 4. Because 360 into 4, 0, 4, 6, 24, 4, 4, 3, 12, 44. So 4 rounds. It will take 5 rounds. It will take 6 rounds. What do you mean by this? After 30 days, it will cover 4 rounds. After completing, where you will reach? You will reach again at a complete round, means from again you will reach at the starting point. So, similarly, it will cover 5 rounds. Again it will reach here. It will cover 6 rounds, because its speed is highest. It is 72. So it will cover 6 times. Again initial, all the 3 persons, they will meet at the initial point and at the starting point after 30 days. So these are some difficult questions relating to HCF and LCM. So if you will go a little bit, you will penetrate to the question and my explanation or my suggestions, it will be somewhat easier to you later on. Okay. Now this is question number 22 and 23. Books of mathematics 240, science 960 and English 1024 are to be stacked in such a way that each stack need be of same quantity of books. What should be maximum number of books can be stacked from each subject, and what are the number of stacks for each subject? In mathematics, science, English, no books or stacks will be left out. Everything will be covered. So, what are the question is given? Mathematics has 240 books, science has 960 books, English has 120 books. Without any hesitation, one will take, if you will put one books, there is no problem. If you will take, but it is the question is, what is the maximum, what should be the maximum number of books? What should be the maximum number of books? We will place that, we will come to the shorter, a lesser, that is self. Because if you will take one books, it will take 240 cells, it will take 960 cells, it will take 1024 cells. Why will do all these things? So if you take their HCF, it will reduce the cell. We cannot put in one cell 5 books, in other cell 6 books. No, not like this. In every cell we will get the equal number of books. So we have to take the HCF. If 1, it will serve no purpose. If we will take 2, there may be some other factors there. We may put 4 books at a time. So we have to factorize in this total. And in HCF, when you factorize for HCF, there must be a common factor in both, in all the numbers. This is a number, this is a number, this is a number. You take such a factor that it must be each and every number, otherwise we cannot find out the HCF. For LCM, if any 2 number has that factor, we can take that as a factor for LCM. But for HCF, each and every number, this 2, you see here. 5 is a factor for 15, 5 is a factor of 60, but 5 is not a factor of 64. So we cannot take 5 as a HCF multiple or a HCF factor. So we left out this one. But when we are calculating LCM, we can take that. But for HCF, the common factor we are taking to this side, it will always be in every number. So it is the process. The other process is written here. The other process is by factorization method. It is the process to find the factorization. What is the factorization method? 240 is equal to, you can look to this, 2 into 2 into 2 into 2 into 2, 15. What is 960? The same thing is for everywhere. The extra is into 60. Similarly, 124 is equal to the same thing into extra thing is 24. In this there is no common. So what will the maximum number? So the maximum 16 book stacks can be made. So 16 books, if you will choose 16 books from this, then we will get certain self, 16 again certain self, 16 again second self. Beyond 16, we cannot stack the books. Or if you less this, you come to this 8, it is wrong, because there is a possibility that we can stack 16, because there is another factor 2. So the maximum is taken as the HCF was taken, that has to come to 16. Now the question is, how many stacks are there? For 240, 15 stacks. For 960, 16 stacks is required. For 120, 64 stacks is required. Because this is the number of this column is known as the HCF, the row is numbered as the stacks. It is written, stacks are the 3 numbers of the last row. Where we further we cannot get the HCF, that the last row is the self and the column portion is the product of the column is the HCF. But it is not the product, it is only the numbers of stacks. Okay. It is very important because generally if you ask any students that you know that HCF and HCF into LCM is equal to product of two numbers. Suppose given since can two numbers have 18 as their HCF and 3 as their LCM, it is 18, it is 380. Oh yeah, HCF into LCM is equal to two numbers. We must get two numbers. It is easy, no problem is there. We can find out any two numbers. But no, there is one restriction, one thinking. What is that clue? Since HCF is a factor of two numbers, that HCF must also be a factor of LCM, because LCM is the number 1 into number 2 is equal to into something is equal to LCM. That may be 1, that may be 2, that may be 3, or whatever that may be. Some additional number is to be multiplied, then only we will get the LCM. But HCF always is here. In number 1, HCF is a factor. In number 2, HCF is also a factor. Automatically, in LCM, HCF and LCM must be a factor. It is obvious. If a number is 1 is multiplied HCF into a certain number, number 2 is also HCF into a certain number, then LCM must have a common factor, that HCF. Suppose 6 and 8. What is the HCF? 2. LCM is LCM. So the LCM is 24. So this 24 divides 2, this 24 divides 2. So always the LCM divides the HCF, or HCF is a factor of LCM. Now here it is the LCM is HCF is given 18, the LCM is given 380, but 18 does not divide 380 because it is a factor of 3, but it is not a factor of 3 because it is 8 plus 3 is equal to 11. 11 is not divisible by 3. The principle you read in your earlier classes, how to check the divisibility of 3, divisibility by 3. So the number is not divisible by 3. Since HCF does not divide the LCM, so these two numbers, two numbers are not possible where the HCF is 18 and the LCM is 380. Okay. Now the rest thing, the case-based questions and some assertion region questions will teach you in details how you will assert, what is assertion, what is region, how they correlate to each other, where it will be not true, where it will be correct, in details. In some after 3 or 4 chapters, at the end of 3 or 4 chapters, I will detail study about the case study and the assertion region, starting for real number, pair of equation, everything else. For this time, the real numbers, the questions and the theory, everything of the real numbers is totally finished. Okay, thanks to all.